Okay, good morning everyone. Today we are going to cover the concept of limiting factors. So to do that, we're going to read up on some of these passages that I have prepared for you. Okay, so let's start off with this. The availability of light, carbon dioxide, and water, and also suitable temperature. So all of these all affect the rate of photosynthesis. However, the rate of photosynthesis in a plant at any given time is governed. This means that it depends on whichever one of these factors is in shortest supply. For example, that factor will limit the rate of photosynthesis. So here we have the word limit, and that's where we get the word limiting factors from. Even though all of the other factors may be ideal or optimum. So even though, for example, carbon dioxide, water, and temperature is the best condition of all, but if light isn't the best condition, then it's going to be the limiting factor. It is the one that is limiting the rate of photosynthesis. These factors are described as limiting factors. So that is the key word of today. Okay, let's read up some more to understand this. So what is a limiting factor actually? A limiting factor is any factor that directly affects a process if the quantity is changed. So this means that that factor, the limiting factor, can either increase or decrease the rate of a process. This process can be a reaction. It can also be a process like photosynthesis. The rate of photosynthesis, what we mean when we say this is that it is the speed at which photosynthesis is occurring at a given amount of time. So we need to look at the clock here. So when we talk about rate, it's about speed. Is it going fast? Is it going to increase? Is it going to decrease? The primary factors that control the rate of photosynthesis. So all of these will control whether or not photosynthesis will be fast. So will occur faster. So the speed of it. And it will also depend on, it will actually affect whether or not the process, the rate. So this is, when we talk about speed, it's always talking about the rate increasing or decreasing. So temperature is a condition. And this is really important because photosynthesis relies on enzymes. Water is really important as well because water is a raw material for photosynthesis. Carbon dioxide is also a raw material. Light intensity is a condition. Even though that it is not a raw material, but how much energy. So light intensity, what it does is that it drives photosynthesis. So it means that if there is that much of light energy, then that is how much energy that can actually speed up this photosynthesis process. So it gives the ability for photosynthesis to occur in the first place. So without light, photosynthesis will not happen. Okay, so we talked about the primary factors here. There are four: temperature, water, light, and carbon dioxide. Water and carbon dioxide are raw materials. Light intensity is a condition. It is the energy, it's the drive for photosynthesis to happen. Temperature is also another condition that's important because of the enzymes. So enzymes rely on optimum temperature. If you guys remember your graph of enzymes, so remember that it goes kind of up and down. So beyond the optimum, you can see that the graph goes down. This means that the enzyme will become denatured. And therefore, if it becomes denatured, then photosynthesis can't occur either. And if the temperature is too low, so this is really low, then you can see that the rate of enzyme action is low as well. It only gets high when you reach this optimum temperature. Okay, so among all of those, we can actually see that the concentration of carbon dioxide, light intensity, and temperature are all external factors. Water availability in a way is, but it's underground. They can only get that underground. Temperature, we can actually control that. And in terms of, let me just see here. Okay, so one thing you need to know is that carbon dioxide, the concentration in the air is always 0.03%. So in real life, carbon dioxide levels will always stay constant. So this is a very important limiting factor. We can only change the carbon dioxide concentration in an experiment, in a lab kind of environment. Okay, so how does this relate to everything else? So in your exams, you will always be kind of shown this graph. You will always be shown a rate of photosynthesis graph. So you can see here on the y-axis. So this is 0. For this one is also the x-axis. And if you can see here, let's focus on the y-axis first. As you move upwards here, the arrow goes up. So that means that our rate of photosynthesis will increase as the arrow goes up. So as the graph goes up, it means that rate of photosynthesis is also increasing. But if the line of the graph touches like below here, down here, that means that the rate of photosynthesis is decreasing. And if it touches 0, that means that there is no photosynthesis happening. And as we move on to the x-axis, we can see that as we move to the right-hand side, light intensity increases here. So how does this actually put everything together? Okay, so let's follow graph 1, the green graph here. We can see that as you increase light intensity, at first we start from 0 here. And then you can see that as we increase light intensity, the rate of photosynthesis also increases. You can see the graph going up. It goes up. It goes up, and that means that it's increasing until it reaches this plateau. It goes straight. So when it reaches this stagnant line, it means that the rate of photosynthesis is not increasing anymore. It's just stuck there. So it's just staying at, let's give this a number. So maybe the rate, let's just say 10. So it's just stuck at 10. It's not increasing any further. But photosynthesis is still occurring. It's just not increasing. So at this graph, you can see that this is where you have 0.03% of carbon dioxide at 20 degrees Celsius. So as you increase light intensity further, rate of photosynthesis is not increasing at point A to point B because it is a straight line. So this means that light intensity is not a limiting factor between point A and point B. Light intensity is a limiting factor around here, this area right here. So whenever the graph kind of slopes up, that's the limiting factor, would be light intensity here. Okay, so now if you move on to graph 2, we increase the temperature to 30 degrees Celsius, but we kept the carbon dioxide constant. So you can see that at this point, right here as well, around point A and point B, that the rate of photosynthesis is also plateaued. But over here before point A, it's increasing. So the limiting factor here is light intensity. But as the graph becomes straight, light intensity no longer becomes the limiting factor. But you can see that 20 degrees Celsius versus 30 degrees Celsius, it actually increased quite a bit, but it's not a very significant increase. So at point A and point B, what we can conclude is that light is not the limiting factor. Temperature is also not a limiting factor because the increase wasn't that big. So now what we did was we are going to increase the carbon dioxide this time, but we're going to keep the temperature constant. So when we increase the carbon dioxide level from 0.03 to 0.13, we can see this shoot up in the graph. It goes up to here now. So let's say that'll be, so this is 10, let's say that's around 20. So now the graph goes up. That means rate of photosynthesis actually reached higher than it was before. And it's at the same temperature, but what we only change is that the carbon dioxide. So from before E right here, you can see that the graph is still going upwards. So there's still an uphill there. That means that limiting factor around here is definitely, before E, is light. So light is the limiting factor here. But beyond point E, because it goes into a straight line, light is no longer the limiting factor. And you can see here that actually the main limiting factor of this graph right here from preventing it from going up is carbon dioxide. So we can conclude that carbon dioxide is the limiting factor. But if we compare, so if the plants were all exposed to 0.13% of carbon dioxide, the limiting factor is no longer carbon dioxide, but the limiting factor here is temperature, because we've already increased the carbon dioxide level, but it stays stagnant here. Light intensity is also not going to increase it as well. But what happened is when we try to increase the temperature, if we give this plant more carbon dioxide, it seems like temperature actually increased in the rate. So it increases the rate of photosynthesis. So at point over here between E and F, the limiting factor here is actually temperature. And limiting factor is not carbon dioxide. All right. I hope that wasn't too confusing, but I'm going to see you this week. So we're going to discuss that even more. So let us try to do this past paper just for you to kind of understand this even more further. Okay. If a condition is a limiting factor for photosynthesis, what does this mean? So changing the condition may either increase or decrease the rate of photosynthesis. That's like a pretty sound definition. Changing the condition will only increase the rate of photosynthesis? Not really. Changing the condition will only decrease. That's a no. Changing the condition will not affect. So that's not a limiting factor. A limiting factor means that if that factor increases or decreases, it's going to also change the rate of photosynthesis. So the answer for this question is A. Question number 2. What graph shows the effect of temperature on the rate of photosynthesis? So we know that photosynthesis relies on enzymes. And the enzyme graph is always like slowly increasing really fast, and then it drops down because it becomes denatured beyond the point of the optimum. So over here, the best graph that looks like the graph for an enzyme. Oh wait, yeah, actually it's D. That's right, because temperature enzymes. Okay. Temperature, light intensity, and carbon dioxide concentration are 3 limiting factors in photosynthesis. In an experiment, each factor is increased in turn. The graph shows the results. So this means that you have one experiment and then they actually change the carbon dioxide, light intensity, and temperature. Okay, for this graph, we are not so sure, right, about carbon dioxide and light intensity, but we know that for temperature, the graph will actually slope down because enzymes. This affects enzymes. It doesn't really affect like other things much more, but the enzymes. So we know that the enzyme graph will look kind of like that and it goes down. So number 3 is the one that looks like it's the temperature one that affects enzymes. So the only answer here we can see is this. So the answer is definitely A. So make sure to look at the clues when you're answering a past paper question. Question number 4, the graph shows the effect of light intensity on the rate of photosynthesis. So over here on the y-axis, it's the rate of photosynthesis, and on the x-axis is the light intensity. What statement could explain what is happening at higher light intensity? So it's asking about this part, because as you move your, what is this called? The x-axis over here is high, here is low. How do I know? Because the arrow is going that way, and this is 0. So anywhere closer to 0 is low light intensity. Anything higher than that, away from that, is high. So we're going to look at this part of the graph. So all the available chloroplasts are fully occupied at light absorption. Maybe. High light intensities increase the temperature above optimum for photosynthesis. We don't know that. The chlorophyll in the chloroplast has been damaged. It won't be damaged because this is light intensity. The chlorophyll actually likes that. They don't really like it, but I'm saying that they could absorb a lot of light. The products of photosynthesis accumulate and inhibit photosynthesis. If this is true, that means that the graph will go down. So that's not true. And the only one that makes sense is this, A. So why is it that when we increase that intensity even more, rate of photosynthesis doesn't increase as well? It doesn't go up. Instead, it goes kind of plateaus. It's because all the available chloroplasts are already fully occupied in light absorption, so you can't absorb any more light. So that means that you can't increase the rate of photosynthesis even further. All right, question number 5. Which graph shows the effect of temperature on the rate of photosynthesis? So we know temperature always affects the enzymes. So we're looking at D. Because beyond the optimum temperature, it will denature all the enzymes that is in charge of photosynthesis. So it is going to go down. The rate will go down because they become denatured. And when you become denatured, you can't do anything. You can't go back. Okay, question number 6. The graph shows the rate of photosynthesis in a plant in full sunlight. So over here, the condition that is at optimum already is sunlight. So sun is okay. And then after that, it says here that there are two different temperatures and different concentrations of carbon dioxide, because we're changing carbon dioxide level here. We know that here. And we also have two graphs at two different temperatures. At normal atmospheric carbon dioxide concentration, what limits the rate of photosynthesis? So this one, we know that the light intensity is already at optimum. So we're going to say no to that one. And normal atmospheric carbon dioxide concentration is 0.03%, right? And so 0.03% is around here. And we're looking at this part of the graph. So when this graph is still increasing like that, that means that the limiting factor here is still carbon dioxide concentration. So this is in November 2012, question 5. So do I have that here? Yes. The answer is A. Yes, I got that right. The answer is A. Nice. Nice one. All right, so for question number 7, the graph shows how two different conditions affect the rate of photosynthesis. So we have graph 1 and we also have graph 2. We know that graph 2 is definitely a temperature graph because it goes down because all the enzymes denatured. So the only answer we have here is this one. So we're going to take B. That is the answer for question number 7. Question number 8. The graph shows the rate of photosynthesis in a pea plant at different light intensity. So light intensity is the one that's changing here. And which point is carbon dioxide concentration the limiting factor? All right. So you have here at light intensity, when you increase the light intensity further, light intensity does not become the limiting factor anymore here, but something else is. So at point A and point B, you can see that the graph is still going up, right? Light intensity is still the limiting factor, because if you increase light intensity, the graph still increases, even at point C. But at point D, you can see that light intensity, when you increase it, it's just going to stay stagnant like that. It still plateaus. But when you increase the carbon dioxide concentration, this line here goes up right there. So that means that the limiting factor, carbon dioxide becomes the limiting factor at point D. That is the answer. Okay, I'm going to finish off with question 9 because I don't have enough time. The graph shows the rate of photosynthesis of a plant at increasing light intensities at two different carbon dioxide concentrations. The temperature is kept constant. What may be the limiting rate of photosynthesis at X, Y, and Z? So at X, we know that if the graph goes up, then the limiting factor is the one down here, so light intensity. At Y, we know that it's not light intensity anymore. So this is correct. At Y, it is carbon dioxide and carbon dioxide. At Z, we can see here, over here. So it's not light anymore, but at this point, if you increase light intensity, it's not going to increase the rate of photosynthesis. So what's limiting it? Carbon dioxide. Because as you increase carbon dioxide, you can see that the graph moves up. All right, so that's it for today. This is confusing. Yes, it is. I'm going to give you some worksheets to do, so some exercises to do. And I want you guys to kind of try it out at home. And then you're going to see me this week, and I'm going to check your answers and we will see if we get the same answers or not. So have a good day, guys. I'll see you guys sometime this week. Bye.